Okay. So last class we discussed about differentiability, and the last class we solved one problem, but we quickly solve that problem. So what is the problem? Suppose exercise f is a function from R to R is differentiable. F is a function from R to R is differentiable function, and n in n. So let n in n and fix a in R. Fix a in R. Find the value. So find limit x goes to a power n f of x minus x power n f of a by x minus a. So what is the value of this limit? We have to add and subtract a power n f of a. So solution. So first you have to consider this. What is a power n f of x minus x power n f of a is equal to a power n f of x. We have to subtract a power n f of a, and then we have to add a power n f of a, and then minus x power n f of a. Now we can take a power n outside from first two term. We have to a power n into f of x minus f of a, and then you can take minus f of a outside. Sorry, f of a. We take f of a outside. You get x power n minus a power n. Okay. Now this is the value of a power n f of x minus x power n f of a, and then now you consider by x minus a. Therefore this is by x minus a, and here we have by x minus a. Now take the limit x goes to a. So limit x goes to a power n f of x minus x power n f of a whole divided by x minus a. This is equal to limit x goes to a power n f of x minus f of a by x minus a minus limit x goes to a f of a into x power n minus a power n by x minus a. Now since this a power n is independent of x, you can take outside from the limit. Therefore a power n into limit x goes to a f of x by f of x minus f of a x minus a. Since we know that given that f is differentiable on R, therefore this is nothing but f dash of a. So this is nothing but f dash of a minus, since f of a is independent of x, you can take f of a outside from the second term, and limit x goes to a x power n minus a power n by x minus. Okay, we can define new function g of x equal to x power n, and this is nothing but g dash of x. Okay, so what is the g dash of x? It's nothing but derivative of this x power n. So this is nothing but n into x power n minus 1. But here we have differential at a, therefore n into a power n minus 1. So this is the value of this limit. Okay, because this x power n minus a power n by x minus a is nothing but derivative of this function g at a point e. Okay, so we can generalize this result into any result. So here we specifically they take the function is g of x equal to x power n. So we can generalize this result into any g of x. Okay. Now we solve some more problems. Again, these are all very important problems. Exercise. Show that the function f of x equal to x into sine 1 by x, where x not equal to 0, and 0 if x equal to 0. Show that this function is continuous at x equal to 0, but not differentiable at x equal to 0. Is continuous at x equal to 0, but not differentiable at x equal to 0. Not differentiable at x equal to 0. So first you have to prove that this continuous at x equal to 0. That means what we have to prove? Limit x goes to 0, f of x equal to f of 0. That is we have to prove. Okay, so continuous at x equal to 0 means what? We have to show that limit x goes to 0, f of x equal to f of 0. That is we have to prove. So but f of 0 we know that 0. So we have to prove that this first. So to prove limit x goes to 0, f of x equal to 0. So how to prove this one? You have to prove that right hand limit and the left hand limit of the function at x equal to 0 is same. So better we take the right hand limit. So first the right hand limit. So that is if we take any sequence xn which is greater than 0 and the xn converges 0, now what is f of xn? So since f of xn is defined to be xn into sine of 1 by xn, and we know that this goes to 0 because the sine 1 by n is bounded by 1 and the xn converges to 0, therefore this sequence is converges to 0. So this is therefore the right hand limit is 0. So what is the left hand limit? If we take any sequence xn which is negative and xn converges to 0, now what is f of xn? Again f of xn is same thing, is that xn into sine 1 by xn. For all non-zero xn, this is the f of xn. Again, since xn goes to 0, minus xn also goes to 0 and sine 1 by xn bounded, therefore this converges to 0. Since both right hand limit, left hand limit exist and both are equal, therefore the limit x goes to 0, f of x equal to 0. 0 is nothing but f of 0. So therefore both right hand limit, left hand limit exist and both are equal, therefore the limit exists. Limit x goes to 0, f of x, the value is 0, but 0 is nothing but f of 0. Therefore f is continuous at x equal to 0. Now we have to prove that the function is not differentiable at x equal to 0. So that means what? The limit x goes to 0, f of x minus f of 0 by x minus 0 not exist. Does not exist. That is for differentiability, right? So f is, we have to prove that f is not differentiable at x equal to 0. But for continuity, you have to check the right hand limit, left hand limit of function f of x. But for differentiability, we have to check the right hand limit, left hand limit of the function. Maybe we call the new function is g of x is nothing but f of x minus f of 0 by x minus 0 is nothing but just x. Okay, so we have to check that the right hand limit, left hand limit of this function g of x. Okay, because we have to check limit x goes to 0, f of x minus f of 0 by x minus 0, we have to check this exists or not. Okay, so that is we have to check the right hand limit, left hand limit of this function, this f of x minus f of 0 by x, we call this g of x. Now we have to find the right hand limit of this new function h. So that means if we take any sequence xn which is greater than 0 and xn converges to 0, then what happens? G of xn. By the definition of g of xn is nothing but f of xn minus f of 0. F of 0 we know that 0 by xn. But xn's are non-zero, therefore f of xn is nothing but xn into sine 1 by xn by xn. Since xn non-zero, we can cancel it. We get sine 1 by n, sine 1 by xn. Since sine 1 by xn not converge, does not exist. Okay, limit does not exist because it's oscillate. Okay, therefore this does not exist. Therefore the this is not differentiable because right hand limit not exist, does not exist. Similarly, we can find that no need to find another limit because one left hand limit, right hand limit not exist. Therefore, the limit does not exist. Therefore, it's not differentiable. Anyway, we can find. We will check what is the left hand limit of the function g of n. So again, if we take any sequence xn which is less than 0 and the xn converges to 0, we will get same thing. But only thing is we get negative things. So it's nothing but f of xn minus f of 0 by xn. But f of xn is nothing but xn into sine of 1 by xn. F of 0 is 0 divided by xn. So xn cancel, we get sine of 1 by xn. Again, this is sign is xn is negative, therefore you will get a minus something. Anyway, again, this is does not exist. Does not exist. Therefore, right hand limit, left hand limit not exists of this function, therefore is not differentiable at x equal to 0. Therefore, f is not differentiable at x equal to 0. Now, we can extend this problem into some other problem. For what values of p, this x power p into sine 1 by x, sine 1 by x. That is the extension of this problem. The f of x is defined to be x power some p times sine of 1 by x, where x non-zero, and 0 if x equal to 0. So if p equal to 1, just now we proved that this is not differentiable at x equal to 0. For what values of p, the function is differentiable, and for what values of e, this is continuous at x equal to 0. So show that actually this is continuous at x equal to 0. So obtain for what values of p such that first f is continuous at x equal to 0. Again, for what values of p, f is differentiable at x equal to 0. But definitely p not equal to 1. If p equal to 1, is continuous but not differentiable. Okay. So similarly, we can replace sine by cos. Again, for what values of p, x f of x equal to x power p into cos of 1 by x, where x not equal to 0, 0 x equal to 0 is continuous at x equal to 0 and differentiable at x equal to 0. So for what values of p. So similarly, we can work that. Okay. So first I solve this one, this problem. What is the solution? So again, we have to find the right hand limit, left hand limit. Okay. So you have to find right hand limit of for continuity. Okay. For check test for continuity. Test for continuity of the function f at the point x equal to 0. So first you have to find the right hand limit, left hand limit of this. Both are x and should be equal to f of 0. So first you have to find the right hand limit of the function f of x. That is, if you take any sequence xn which is greater than 0 and xn converges 0, we have to check what is f of xn. So by the definition f of xn, all the xn's are positive. Therefore, this is nothing but xn power p into sine of 1 by xn. Okay. And we know that if p is greater than 0, then it always converges to 0. Because sine 1 by x bounded by 1, and this already we know that this converges to 0. Therefore, at least p should be 1. Okay. Therefore, if p equal to 1, then this should be differentiable. Therefore, this is converges to 0 only when p is at least 1. Therefore, greater than or equal to 1. If p greater than or equal to 1, this always converges to 0. Therefore, the right hand limit exists and the limit is 0. So similarly, for left hand limit, again, if you take any sequence xn which is less than 0 and the xn converges to 0, then f of xn is, you will get same thing, xn power p into sine of 1 by xn. Again, sine 1 by xn bounded, and xn power p is converges to 0 only when p should be greater than or equal to 1. Okay. At least p should be 1. So therefore, both right hand limit, left hand limit exist. Therefore, limit exists. The limit is 0. Therefore, limit x goes to 0, f of x equal to f of 0, where p greater than or equal to 1. If p equal to 1 or p equal to anything bigger than 1 is always continuous. Okay. Now, what about differentiability? Even not only actually p greater than 0, p greater than 1, if you take any positive number, okay, therefore better we can take except 0. Therefore, we can rewrite it. Anyway, we need a sequence here which converges to 0. We can take anything, but p should be greater than 0. If we take any p which is greater than 0, is always converges to 0. Okay. Therefore, is continuous for any p which is strictly greater than 0. Okay. Now, therefore, this function is continuous for any p greater than 0. So next, test for differentiability of a function at a point x equal to 0. So test for differentiability. Test for differentiability of the function f at the point x equal to 0. So now we have to check the right hand limit, left hand limit of a function g of x. That is g of x. G of x nothing but f of x minus f of 0 by x minus 0. That is f of x minus f of 0 by x minus 0. But already we know that f of 0 is 0. Therefore, just we have to check f of x by x. We have to find the right hand limit, left hand limit of this one. So first, what is the right hand limit? Right hand limit of the function g of x. Therefore, if we take any sequence xn which is greater than 0 and the xn converges to 0, then what is g of xn? So by g of xn is nothing but f of xn by xn. So f of xn nothing but x power p, xn power p. You can take this, we one cancel one p, and therefore xn power p minus 1 into sine of 1 by xn. Okay. When this converges to 0, only when this p minus 1 is positive. Okay. That means what? The p is greater than 1. If p is greater than 1, then the right hand limit exists. Okay. Now, what about the left hand limit? Similarly, same thing. So the left hand limit of the function g of x, that is, if we take any sequence xn which is less than 0 and the xn converges 0, then what is g of xn? So g of xn again f of xn by xn. Again, we can write xn power p minus 1 sine of 1 by xn. And when this converges 0, only when this power is positive. That is, p minus 1 is positive. That is, p is greater than 1. Therefore, the function is differentiable only at p is strictly greater than 1. If p equal to 1, that is not differentiable. We solved the previous problem. Okay. Therefore, the function x power p sine 1 by x is differentiable only at p strictly greater than 1, continuous at any p greater than 0. Okay. Now, once it's differentiable, now what is the derivative of this one? So, what is f dash of x is nothing but what is that? This you have to apply u by v. This is a product of two functions. You have to apply uv method and then write the derivative here. Derivative of 0 is 0 here. Okay. So, after that, you have to check this f dash is differentiable or not. Okay. Again, for what values of this? Sometimes f dash is does not exist. Okay. But maybe I will give one more problem in terms of x square. But this problem for p is greater than 0, continuous, p greater than 1 is differentiable. Okay. So similarly, particular case, if you take p equal to 2, what will happen? So for example, f of x is defined to be x square into sine 1 by x for x not equal to 0 and 0 x equal to 0. Now clearly this is different continuous. Even it is differentiable because this p is greater than 1 because p is 2. Therefore, this f is both differentiable and continuous at x equal to 0. Now, what about, therefore, is differentiable, therefore, derivative exists. Now, what okay, then we got to show that f is derivatable for every value, but the derivative is not continuous. Okay, so f is already we know that f is continuous and differentiable at a point x equal to 0. Okay, but this f dash is not continuous at a point x equal to 0. Why? Then what is the derivative? So the derivative of f is nothing but f dash of x. You have to apply uv method. So first we have to differentiate x square. We get 2x into sine 1 by x uv. Okay, and then plus you have to fix x square and then differentiate sine 1 by x. Sine 1 by x is nothing but cos 1 by x, and then you have to differentiate 1 by x is nothing but minus 1 by x square. So this is the derivative of your function at a point x not equal to 0. For x equal to 0, we get 0. Therefore, finally, what we'll get? So this is nothing but 2x into sine 1 by x and minus x square cancel, we get cos of 1 by x. So this is our f dash of x. So therefore f dash of x equal to this, where x not equal to 0, and 0 where x equal to 0. Now we got to show that this f dash is not continuous at x equal to 0. So that means we have to find the limit x goes to 0, f dash of x not equal to f dash of 0. Okay, this is actually, this 0 is the f dash of 0. So now we have to find the right hand limit, left hand limit of this f dash. Okay, what we'll get? So the right hand limit of this f dash. So that is, if you take any sequence xn which is greater than 0 and the xn converges 0, then what is f dash of xn? So f dash of xn. So f dash of xn is nothing but 2xn into sine of 1 by xn minus cos of 1 by xn. As xn goes to 0, this is bounded and this is goes to 0. Therefore, this term converges 0, but this term does not exist. Okay, because cos of 1 by x, sine of 1 by x oscillates between 1 and minus 1. Therefore, the first term limit exists, but the second term does not exist. Therefore, totally the limit does not exist. Okay, so therefore this limit does not exist. Therefore, the right hand limit not exist. Similarly, we can find the left hand limit. Again, you will get anyway one side limit is not exist. The limit does not exist. Therefore, the function is discontinuous. You can say the type of discontinuous. Say there is a first kind or second kind. You can say depending upon this one. Okay. Okay. So therefore, the right hand limit does not exist because it oscillates between this cos of 1 by x and oscillate between 1 and minus 1. Therefore, does not exist. Okay. So the function is continuous and then differentiable at x equal to 0, but it's not continuous. The f dash is not continuous. Since it's not continuous, therefore it's not differentiable, because every differential function is continuous. Since we know that this is not, f dash is not continuous, therefore f dash is not differentiable. Again, we cannot find f double dash. F double dash not exist because f dash is not continuous. Because already we know that the necessary condition for differentiability is the continuous. Since f dash is not continuous, therefore f dash is not differentiable. Okay, so this type of problem they will ask for what values of p, this is differentiable and so on. Okay, now you can try similar type of problems in the book. You can solve it. Now another important theorem. So already we know that mean value theorem, Rolle's theorem for a function. Now there is another important theorem. This is a Darboux theorem. Darboux theorem. So this actually like mean value theorem for derivative of function. Darboux theorem. This is also very important theorem. So what is the theorem statement say? Suppose a function is differentiable in the closed interval a comma b. So that is, suppose let f is a function from closed interval a comma b to r be differentiable. So they say differentiable, it automatically continuous. Okay, and the f dash of a, because the derivative exists, right? So this f dash of a and this f dash of b are opposite sign, or opposite sign. So that is means what? F dash of a is less than 0 and f dash of b is greater than 0. That is opposite sign, means this is happen. Then there exists c in open interval a comma b such that f dash of c equal to 0. Okay, then there exists c in open interval a comma b such that f dash of c equal to 0. Okay, so this is the Darboux theorem. So Darboux theorem is nothing but just the mean value theorem or the intermediate value theorem for derivative of a function. Okay. That's a very important thing. Now almost we discuss about the differentiability, and then we next to move to the. So already we studied the L hospital rule. Okay, once we studied that maxima and minima. So far any doubt you can ask the differentiability. So you have to find the right hand limit and the left hand limit of your function. Both exist and both are equal, then the derivatives exist. Okay. Now similarly we can define any higher order derivatives. Okay. So far we discussed about only first order. You can generalize for the nth order higher derivatives. Now using the higher derivatives, we state the Taylor's theorem. So any differential function we can express as a series, power series. That is a Taylor's theorem. Maybe I wrote. Okay, better we move to that maxima and minima, and then we say we will discuss later Taylor's theorem. So Taylor's theorem is nothing but we have to express. Suppose f is a continuous function, then we have to express f of x plus h is nothing but f of x plus h 1 factorial into f dash of x and so on. So plus h square by 2 factorial into f double dash of x and so on. But anyway, we will discuss that later. So any differential function, continuous differential function can be expressed as a power series, that is Taylor series theorem says. Now the next thing is maxima and minima. So maxima and minima is nothing but just you have to find the derivative, and then you have to find the critical point, and then you have to find the maximum and the minimum. Maxima and the minima of your function. So when we say the function is said to be maximum value at a point C, if you take any other points, the value should be less than that point. Okay. Suppose if C is any interior point, C is in open interval A comma B. Suppose C is in any point of your function C f. Now, when we say this f of C is maximum, is said to be maximum value. Is said to be maximum value of your function. Maximum value of your function if there is some neighborhood of C such that f of C is bigger than any other value, any other point in the same. So if there exists some neighborhood we call C plus some C minus h to C plus h, or C minus delta to C plus delta, some neighborhood of C, some open interval of C. So there is neighborhood of C such that if we take any point in the interval, such that if we take any point x in the interval C minus delta to C plus delta, but x not equal to C, such that f of C is bigger than this f of x. Okay, then we say f of C is the maximum value of the function in the domain. Okay, so similarly we define the minimum is nothing but f of C is smaller than f of x for all x. So similarly we define minimum, so it's nothing but again for x there is some neighborhood such that f of C is less than f of x for all x, then f of C is the said to be minimum value of the function. The minimum value exists at a point x equal to C. So when we say a function is said to be extremum value, is either maximum or minimum. Okay. And next we say that f of C is said to be extremum value. F of C is said to be extremum value, extreme value always, not extremum, extreme value. extreme value, if extreme value of f, if it is either maximum or minimum, if it is either this f of c is maximum or minimum. Okay. Now we have some theorem. What is the necessary condition for existence of extremum value? When a function have a extremum value exists, so then f dash in this case should be 0. So theorem, what the theorem says, suppose if f of c is an extremum value, if f of c is an extreme value of f, then the derivative of the function at a point c is 0. So then f dash of c in both the cases, if you take minimum or maximum, then f dash of c, if in the case exists, if it is exist, in case it exists, then it should be 0. Is 0. Okay. So if f of c is a extremum value, extremum means or either maximum or minimum, that f dash of c should be 0. Okay. That is very important thing. Now, what is the sufficient criteria to existence of extremum value? That is a first derivative test. So how to check, how to find the maximum value, minimum value of your function? So first you have to take the function. Okay, so maybe I state the theorem. So the theorem is called first derivative test. First derivative test. So what the test is, let f be the differentiable function in the neighborhood of c. Okay, where f has a extremum value at c. So let f be the function. Let a function f be differentiable or derivable in the neighborhood of c. In a neighborhood of a point c where f has an extreme value at a c, where f has extreme value at a c. So then when we say f of c is a maximum value, it's a maximum value if the sign of f dash, if the sign of f dash changes from plus to minus, changes from plus to minus. And when we say f of c is minimum, if the sign of f dash does not exist, or if that exists, then it vanishes throughout. Okay, changes. Okay, sorry, changes from minus to plus, opposite. Changes from minus to plus as excess passes through c. as x passes through C. Okay, maybe we discuss some example. So find the value of x for which the function is defined by this. Find the maximum or minimum. So for what values of x the function is maximum, for what values of x the function is minimum. So problem exercise. So if take the function f of x equal to x power 5 minus 5x power 4 plus 5x power 3 minus 1. Okay, where x varies in the real number r. Now find the values of x for which the function is maximum and minimum. So first you have to take the derivative and then you have to take equal to 0, find the values of x. That is a critical point, so we say. So what is f dash of x? So you have to differentiate term by term. So the f dash of x equal to 5 times x power 4 minus 20 x cube minus plus 15 x square, and derivative of 1 is 0. And then you have to take this equal to 0 and then you have to solve it. So you can take x square outside from all the terms. So x square into 5x square minus 20x plus 15 equal to 0. Okay. So therefore x equal to 0 is one of the root, because x square is a factor. Therefore x equal to 0 is one of the root. Now what is the root of this? Okay. So you can divide 5. Therefore we get x square minus 4 times x plus 3, right, equal to 0. If you divide both sides by 5, you'll get this one. Now the sum of the root is 4, product of the root is 3. Therefore 1 into 3. Okay, therefore x equal to 1 is a solution, x equal to 3 is also a solution. Okay, therefore there are 3 solutions distinct, because 0 is repeated 2 times. Therefore these are the only distinct solutions of this equation. Therefore these are called critical point. Critical points. Okay. Now you have to change slightly changes what is the derivative f dash. You got to substitute the values and then you have to check is the f dash changes or not, the sign of x changes or not. Okay. Now for x slightly less than 0, then what is f dash of x? So if x is less than 0, then look at this equation. Maybe we call this equation number 1. So this is our f dash. If s is slightly less than 0, then it should be f dash of x should be what? Is positive. Okay, because look at this is an even power, this is also even power. If this is negative, then we have a minus sign is in that coefficient, therefore this should be plus. Okay, everything should be positive term, therefore f dash should be positive. For x is negative, we get f dash is positive. Okay, suppose if x is positive, then again still you will get f dash of x is positive. Okay, because you will get this is 5 and then 15. So if it slightly changes the x is positive, then you will get this term is bigger than this term. Therefore, we'll get always positive. Okay.
Sir,
Yeah.
we should check for f double dash, no, sir? Or f dash.
Yeah. Double dash, you can, there is a, okay, yeah, there is another method. You have to find the x double dash and then so you have to substitute the critical point for what values of, if you get negative value, that is a maximum value. If you get the f double dash negative, that should be a maximum value. Hey, if you go that one, it's okay. So you have to find the f double dash. What is f double dash of x? Is nothing but 20 times x power 3 minus 60 x square plus 30x. So you have double dash. Now you have to substitute the critical points. If substitute x equal to 0, f dash of 0 equal to 0. and f double dash of 1 is 50 and then minus 10. Okay, and f double dash of 3 is, you'll get a big number, right? So 20 into 27.
So positive, sir.
Sorry.
For x is equal to 3, we get positive value, sir.
Yeah, okay. For positive value, here you'll get negative value. So therefore, so for what values of x? So if it is f double dash is negative, then this is a maximum value. So at the point x equal to 1, you'll get the maximum value. You substitute x equal to 1 in the given f of x, you'll get a maximum. What is the f of 1? F of 1 is nothing but 0. Okay. What is f of 3?
F of 1 negative. F of 1.
No, actually, you got the maximum at x equal to 1, minimum at x equal to 3. So so first you have to take the first derivative, and then you have to take equal to 0 and then find the critical point, and then you have to find the second derivative. You have to substitute the critical point in the second derivative. For what? Suppose if the second derivative is negative, that point is the maximum point. If the second derivative is positive, that point is the minimum point. So that is the theory. So here we got f double dash of 3 is positive. Therefore, 3 is the minimum value. So what is the minimum value? You have to take f of 3. So f of 3 is minimum. Okay. And f of 1 is maximum. Okay, that is the idea. So we don't take too much time to this, because first you have to take the first derivative, and then you have to take this equal to 0 and then find the values of x. That is a critical point. You have to find the second derivative and then substitute the critical point in the second derivative. You will get a negative. Then that point is maximum value. Maximum value exists at the point x equal to 1. That is, the maximum value is nothing but f of 1. So f double dash of 3 is negative positive. Therefore, we'll get a minimum at the value 3. The minimum value is nothing but f of 3. Okay. So that is a idea. So maybe any doubt in this? So that is simple idea. How to find the maximum minimum? This is a simple idea. You have to find the first, you have to take the derivative and then equal to 0, find the values of x. And then you have to find the second derivative, substitute the values on the second derivative. You'll get the negative value, that is the maximum value exists at that point. And then you have to substitute that point to the given f of x, that is the maximum value. We get a f double dash is positive, that is a minimum value exists at that point, and then the minimum value is nothing but f of that point. Okay, so that is a simple thing. We don't want to spend more time on this. Okay, it's a simple idea. So we have so many problems are there. You just try it, you'll get. Now we move to the yellow spinner. Any doubt in this? The simple idea. Okay. So you already studied yellow spinner, right? So maybe we discuss quickly. We discuss how to find the limit of some function. If the none of the function limit does not exist, or 0 or infinity, then how to find the limit. So that is we call the intermediate forms. Intermediate indeterminate form. Indeterminate form. So the first intermediate form is 0 by 0. Okay. So the first intermediate form is 0 by 0 form. So that is what the theorem says. First theorem. Suppose we have a two function f and g. So let f comma g be two functions such that such that first the limit x goes to c, f of x is 0, and limit x goes to z, x goes to c, g of x also 0. And the second condition is f dash of x, g dash of x both exist, but g dash of x not equal to 0. So f dash of c also exists, and then g dash of c also exists. Okay, and that should be non-zero. G dash of c should be non-zero. Then what is the limit of the quotient? Then limit x goes to c, f of x by g of x. So we already know that this is a limit f of x by limit g of x, but we'll get 0, 0. Therefore, this is nothing but you have to take f dash of c by g dash of c. You have to take the first derivative of the numerator, derivative of denominator, and then take the limit, you'll get. So this is the limit of this function. Okay, provided the limit of f is 0, limit of g is 0. So this is the first form. Okay, so that is a 0 by 0 form. So the next one is actually this is L hospital rule 2-1 maybe. So this is a form, but we can say L hospital rule is nothing but the limit is this, then the limit of the original is same thing, same f dash of c by g dash of c. So we can extend into anything. So up to you'll get non-zero g dash, you can go it. So again, suppose limit of f dash is 0, limit of g dash is 0, then limit is nothing but f double dash of c by g double dash of c, and so on. So we can go up to, we'll get up to non-zero. So maybe state as a theorem. So what is the next theorem? Suppose we have two functions f and g. If f, g be two function, such that as when x goes to c, when x approaches to c, then the first one is, so limit x goes to c. Anyway, I already wrote x goes to c, f of x is equal to limit f dash of x, f double dash of x, and so on, etc. up to the nth derivative, n minus 1th derivative of the function, all are 0. So similarly for g, so limit x goes to c, g of x is 0, limit x goes to c, g dash of x is 0, and so on, limit g n minus 1, the derivative of the point is 0, then, and third condition is the derivative, nth derivative exists at a point c. So that is f nth derivative of c and g nth derivative of c exist, and the g nth derivative of c is non-zero, then the theorem says limit x goes to c, f of x by g of x is nothing but the f nth derivative of c by g nth derivative of c. So until you get a non-zero limit, you can take the derivative. So that is a L-Hospital rule. Okay, this is a first intermediate form, indeterminate form. The next one is infinite by infinite. Infinite by infinite, again you'll get the same thing. Okay, you have to find the limit. We state as another. So the next form is infinity by infinity indeterminate form. So in that form, what is the theorem? Theorem. Suppose we have two functions such that one function, that is limit x goes to c, g of x is infinity. Okay. again f of x also infinity, then limit x goes to c, f of x also infinity, and okay, maybe you can generalize that result into L. So then limit x goes to c, f of x by g of x, the value is nothing but f dash of c by g dash of c, provided g dash of c is non-zero, and then f dash of c, g dash of c exist. Okay, so you are all studied these things in your class, right? So L'Hospital rule, infinity by infinity, 0 by 0. So if any other form, you can convert into either one of the form. Maybe we'll discuss some examples to find the limit of the function. The first one is find the limit x goes to 1, x cube plus 3x minus 4 by 2x square plus x minus 3. So the numerator function is f of x. If substitute x equal to 1, we get 0. Again, in the denominator also, if substitute x equal to 1, we get 0. By L'Hospital rule, you got to take the differentiation. Therefore, limit x goes to 1. What is the derivative of the numerator? 3x square plus 3 divided by 4x plus 1. Now, if substitute x approaches to 1, you'll get the numerator is 6. The denominator we have 1. Sorry, 4. Therefore, 3 by 2. So, 3 by 2 is the limit of this function. Now, the next thing. So, evaluate limit x approaches to 0, x into cot x minus 1 by x square. So, again, if you want, you can change it. So, cot x is nothing but cos by sine. So, we can rewrite this as limit x goes to 0, x into cot x is nothing but cos by sine. Therefore, cos x, you got to cross sine x here by x square into sine x. Okay, if you simplify this, you'll get this one. Now, as x approaches 0, you'll get 0 by 0 format. Therefore, by L'Hospital, you got to differentiate numerator and the differentiate denominator. So, in the denominator, we have a product of two functions. Therefore, you have to apply UV method. So, therefore, in the numerator, we got therefore limit x goes to 0. Again, x into cos x. Therefore, you have to fix x, differentiate cos is nothing but minus sine x plus fix cos x, and then differentiate x is 1 minus sin x derivative is cos x. Sin x, cos x plus cos x minus x cancel anyway. So fix x square, differentiate sin x, you'll get cos x plus sin x into 2x. Okay, now again you'll get a 0 by 0 format. So again you got to differentiate. So this cancel. So anyway, finally you'll get minus 1 by 3. So you can again you got to apply x goes to 0, you get 0 by 0 format. Again you got to differentiate denominator numerator, and then you got to substitute x equal to 0. Not substitute, limit x goes to 0. You get if not get anything, 0 by form or infinity by infinity form, that is a value, that is minus 1 by 3. Okay. Now this is a L'Hospital rule form, either infinity by infinity or 0 by 0 form. Suppose we have a 0 into infinity form, then we have to rewrite the function and then you have to simplify. Okay, so the next form is infinity into 0 form, 0 into infinity form. So in that form, suppose what the theorem says, so limit x goes to c, f of x is we get 0, and the limit of x goes to c, g of x is infinity. So then this f of x into g of x, what is the limit of this product of two function? You will have 0 to infinity. Then we can rewrite this limit x goes to c, f of x by 1 by g of x. Okay. So therefore, 1 by g of x nothing but again g of x. Okay. Now we can substitute limit x, if you take x equal to 0, we get 0 by 0 format, because 1 by infinity is 0. And then again you got to take the differentiation of this, again you got to take the derivative of this, and then substitute x, take x goes to 0, you will get this one. So we got to convert this 0 by 0 into infinity form into 0 by 0 format, replacing the infinity term. Since here we get infinity for the function g of x, therefore you got to take 1 by g of x. You will get the answer. For example, for this problem, for this form exercise, so evaluate the limit x goes to 1 minus x into tan of pi x by 2. Now if substitute approaches to x equal to 1, this goes to 0, and this is tan pi by 2. Tan pi by 2 is infinity, therefore is a form 0 into infinity form. Therefore we can replace or rewrite this as nothing but limit x goes to 1 minus x by 1 by tan. 1 by tan is nothing but cot of pi x by 2. Okay, now we can simplify, got to differentiate numerator and differentiator. If we differentiate numerator, we get minus 1. Okay, limit x goes to 1. So in the denominator, what is the derivative of cot is nothing but cosecant square x pi x by 2, and then minus cosecant square x by 2, and then derivative of pi by x by 2 is nothing but pi by 2. Now again substitute as x approaches to 1, you will get minus minus cancel, you get a 1, therefore you get 2 by pi. Okay, because the cosecant square is nothing but 1 by sine square. So sine pi by 2 is 1, therefore you will get a 2 by pi. Okay, therefore you have to convert 0 into infinity form into 0 by 0 format. Now another form is infinity minus infinity form. Suppose we have a function get infinity minus infinity form, we have to convert into 0 by 0 form. So how to convert? So infinity minus infinity form. So that is f of x minus g of x. F of x limit 0, g of x minus limit is 0. Now we have to rewrite is f of x can be written as 1 by f of x minus g of x can be written as 1 by g of x. Okay. Now what you will get? So you can you can cross multiply this, you will get 1 by g of x, and then minus you cross multiply this, you get 1 by f of x all divided by 1 by f of x into g of x. Now this g of x is infinity, therefore 1 by infinity is 0. Actually this is 0, sorry, this is 0. Again this is also 0. 0 minus 0 is 0. In the numerator we get 0. So in the denominator again we get 0. So you get 0 by 0 format. Therefore you got to differentiate numerator and then differentiate denominator, and then take the limit x goes to 0. So therefore this function can be rewrite into this, and if you simplify this, you will get this one. 1 by g of x minus 1 by f of x by 1 by f of x into g of x. And here we'll get 0 by 0 format. Then you can differentiate numerator and then denominator. You will get answer. Okay. Now this is another form. So in the next another possible forms are 0 power 0. So other possible forms are 0 power 0 and then infinity power 0 and then 1 power infinity. Now you have to take logarithmic of this one. Suppose L is the limit of a function f of x power another function g of x. If you take x goes to c, you'll get either 0 power 0 or infinity power 0 or 1 power infinity. Then you have to take log both sides. Therefore, log L equal to limit x goes to c g of x into log of f of x. Okay. and then you have to apply thing. You have to find, now you will get maybe 0 into infinity form or in anything is of the form. So now maybe this is 0 into infinity form or any other form, then we got to convert into 0 by 0 form. Already we discussed, right? So once you get, you got to solve it. Finally you got to take the raise the take exponential both side. You'll get L equal to e power. If you get the values k, then you'll get L power k, L equal to e power k. Suppose the value is k, then final L equal to e power k. Maybe we will discuss one example to this form. Suppose x power x. Exercise, find the limit x goes to 0, x power x. So this also forms 0 power 0, right? Therefore we call the limit is L. Okay, now take log both side. Therefore log L equal to limit x goes to 0, x into log x. Now what is this of the form? 0 into log 0. So what is the log 0? Is infinity. Is not defined. We called actually infinity. This is of the form 0 into infinity form. So therefore we have to write in the 0 by 0 form. So that is limit x goes to 0, x by, so we get infinity for this term. Therefore we got to write 1 by 1 by log x. Okay, this is nothing but, okay, either we can convert into 0 by 0 form or infinity by infinity. So maybe we can write it's infinity by infinity. Therefore we can take this x to the numerator, that is 1 by x. So therefore log x by 1 by x. So you'll get infinity by infinity form. Therefore you got to differentiate numerator and the denominator and then substitute. Take limit x goes to 0. What is the derivative of log x? Is nothing but 1 by x. What is the derivative of 1 by x square? 1 by x is minus 1 by x square. Okay, now we can cancel it. We'll get x limit x goes to 0 minus x. Okay, this is nothing but 0. So this is actually L. Log L equal to 0. Therefore what is L? E power 0. So therefore it's nothing but 1. Therefore the limit value is nothing but 1. Okay, so we have to convert into either 0 by 0 form or infinity by infinity form, and then you have to apply. Okay, so there are plenty of theorems are there. You just go through it, then you can convert either one of the form, either 0 by 0 or infinity by infinity. You'll get answer. Okay, any doubt in this? Okay, maybe in the next class we discuss the Riemann integrability. That is very important theme. Okay, now we stop the class. Thank you.